Alright, so we're back where I left last video. We had the situation where at first, let's just erase that here. Let's call this before and this after. Alright. So what we did last time was to consider what happens, what is the situation when we look at the momentum calculations or energy, momentum calculations before, and what happens after. This is before and this is after, because at first we just have the mass of the bullets times the velocity, and then in the second situation we have the mass of the bullet. Let's put it here. Mass of the bullet plus the mass of the wood times some velocity. I didn't put it in here. The block of wood has some velocity that we call V2. Yeah. And then the block of wood moves a distance upwards that we call Y. There. So at first we look at the momentum calculations. Let's put it here. Momentum. Then we look at the kinetic energy. And then we can say that the kinetic energy before and after have to be 1/2 the mass of the bullet plus the mass of the wood. Now we just say that the kinetic energy is this, and then we can, because we look at this system, we can rewrite it to say that it must be equal to the mass of the bullet plus the mass of the wood times Gy. Alright? And let me tell you why. That is because we say that the kinetic energy and the potential energy have to be similar. Alright. So what we say now is that we can rearrange all that to get that V2 is equal to the square root of 2Gy. Now what we do now is that we take this result here. Let me just put that in a little box. We take this result here, then we put it inside our momentum calculation that we have rearranged here. So we get that V1 is equal to mb plus mw over mb times V2, but we have this new V2, so we put in instead square root 2Gy. And let's say, for instance, let's pick some good numbers. Let's say that the mass of the bullets is equal to 5 times 10 to the minus 3 kilograms. The mass of the wood is 2 kilograms. And that we have measured this Y here to be 3 times 10 to the minus 2 meters, that's 3 centimeters. Alright, so now we can put this in, and that gives us 5 times 10 to the minus 3 times 2, I think it is, yeah, 2 divided by 5 times 10 to the minus 3 times the square root of 2 times 9.82 times this number here, 3 times 10 to the minus 2. Now if you calculate this number, you'll get that the speed of the bullet should be 307 meters per second. Now this is just in order to illustrate more exactly what do we mean by an inelastic collision. And in this system, the reason why this is an inelastic collision, and as I said before, that energy is not conserved, is that the total energy in the system is not conserved, and that is because as the bullet hits the block, the block of wood, there is a frictional force doing work on the system to stop the bullet inside the block. So some energy is being used in there. But in this is a simple setup that you can calculate the speed of an inelastic system, to calculate the speed of a bullet without knowing anything about the bullet other than the mass. Alright, so what is an example of an elastic collision? Like I said, an elastic collision could be if we have a billiard ball where this is still and this is moving with some speed, and then after the collision they both have some speed. So that's considered an elastic collision because we don't consider any exchange or usage of energy in this collision. There is some small amount of energy is actually being converted into thermal energy inside these frictional thermal energy inside the balls at the collision, and also as the ball slides over, there's also a small amount, but that is negligible if in considering of the system.